All right, what's up, guys? So we're finishing up Unit 1. Actually, this is not the correct um, PowerPoint. So hold on. Let's get the right PowerPoint up. Let's see. All right, hold on. I'll be right. All right. Sorry about that. Um, you would have thought that I would have maybe brought my screen up first before doing it. Um, all right. Now we're off and running. All right, so we're doing significant digits and scientific notation. I'm going to tell you right now, right out of the chute, the significant digits piece, I may ask you one question on a test, maybe, about it. I don't necessarily, I get the idea of significant digits. It talks about accuracy and it talks about precision in numbers. What's significant, what's not. I don't agree with all the rules there are with it. I think it's kind of silly at times. So that's where I'm at. All right, so let's start today's stuff. So, scientific notation, I like to say, is all about scientists being absolutely 100% lazy, but not really. They're working smarter and not harder. So, scientific notation allows anybody, but usually scientists, to write really, really, really big numbers quickly, as well as really, 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 really small numbers quickly. So it gives it the opportunity to not have so many numbers in a quote unquote number. So by using powers of 10, you can create quick versions of really large magnitude numbers as well as very small magnitude numbers, multiple decimal spots. You'll see once we start showing the examples. So in this case, 1,453,980,401. We can rewrite that as a decimal or as a and scientific notation by taking the decimal, which would be here at the end, and moving the decimal to 9, almost 12 spots between the 1 and the 0. Because all scientific notation coefficients must be between 1.0 and 9.9 for it to be in scientific notation. So in this case, it's 1.0045639804001 times 10 to the 12. Now, I would be honest with you and say, if you put 1.00 times 10 to the 12th, I would accept that because that is correct. But beside the point, that would be the number because you moved the decimal from here to here, and it's 12 spots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right. So standard notation 47. Okay. In this case, you're moving the decimal one spot. So it's going to be 4.7 times 10 to the first. Okay. So 10 to the first is always 10. So it is what it is. Okay, I paused. Good. All right, I'm back. Sorry about that. And we want to share. Nope, not that. Uh-oh. Where'd it go? Mm-hmm. Here it is. Okay. It's been a tough day already. Good Lord. All right. So we talked about scientific numbers, standard notation, scientific notation. Standard notation would be like writing it out regularly with all the spots. Scientific notation puts it to a base 10, makes the coefficient between a 1.0 and a 9.9. So looking at these two numbers here, you have a decimal. Start with a decimal. You have to move it to the right to get to between between the 5 and the 8 to make sure your coefficient is between 1 and 9.9. So your scientific notation is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You move it 12 spots to the right because it's a decimal. And because these numbers are positive exponents, this decimal is going to be a negative exponent. This moves to the left, that's positive. This moves to the right, it's negative. Okay. And then this bottom one, you just move it 1, 9, and that gives you 6.9390 by 10 to the negative first. So some quick rules and tips. First, base 10 always. You're always putting some coefficient, and you're going to take that number and set it to multiply it by a base 10. Okay. Secondly, that coefficient, that number out front, will always be between 1.0 and 9.9. If it's not in scientific notation. All right. The exponent is always attached to the base 10. There will always be an exponent attached to the base 10. It can be either positive or negative, depending on what you start with number-wise. And then number 4, find where the decimal is. If the decimal, find it wherever it is, and then move it to make a number for the coefficient between 1 and 9.99. And however many spots you move it, that's going to be your exponent. And if you're moving it left, it's going to be positive. If you're moving it right, it's going to be negative. All right. So those are the quick rules of scientific notation. The coefficient must be between 1.0 and 9.9. Everything's set to base 10. And then your exponent is however many spots you've moved the decimal to make the coefficient between 1 and 9.99. All right. So these are tips to help you ace scientific notation. So the first tip is standard notation. If your number is greater than 1, so if it's 1,212, your exponent will always be positive. If it's less than 1, like 0.0042, your exponent will always be negative. So that's the easy way to remember it for standard notation numbers. If it's over 1 and it's 1.275, it's going to be a positive exponent. It would be 1.275 to the third. If it's 0.0042, it's going to be 4.2 times 10 to the negative third. All right, so that's standard notation. Second rule, however many spaces you move the decimal, that will be the exponent. So either positive or negative. If it's moving left, it's going to be positive. If it's moving right, it's going to be negative. The positive or negative exponent, if the decimal moves left, then it's positive. And if it moves to the right, then it's going to be negative. Fourth, base 10 every time. It's a coefficient times 10 to some exponent. Okay, you have to make sure that you're writing it in the proper format. And fifth, coefficient has to be between 1.0 and 9.9. The number out front is not. It will not meet scientific notation rules. And if the standard notation number is negative, so say negative 15, say negative 152, then it's going to be the coefficient that's negative, not the exponent. So it would be a negative 1.52 times 10, 2 to the second. Okay. So just keep that in mind. If it's a negative number, you can still put it in scientific notation. You just have to make sure that the negative is in front of the coefficient. Now, if it's a negative decimal, then you're going to have the negative out in front of the coefficient, and you're going to have the negative sign also up in the exponent as well. All right, so some examples. 4.629 times 10 to the 6th put into standard notation. Sorry. I didn't think I had the answers. I wasn't sure. So 4.629 into standard notation. So your decimal is here. You're going to move it 1, 2, 3 spots. You still have 3 spots to go, so you're going to add 3 zeros to the number. Okay? So you're going to add 3 zeros to that number. And when you put it in scientific notation, it's going to be 4, 6, 2, 9, 1, 2, 3. Okay? So you moved it 6 spots. Now, for this one, you're putting it in scientific notation. So you have to take the decimal, which is at the end of the number because there's no decimal in the middle. Decimal's at the end of the number. You're going to move it 1, 2, 3, 4, 5, 6, 7. You're going to move it 7 spots. And because you're moving it to the left, the exponent is going to be positive, and you moved it 7 spots. So it's the exponent is going to be 7. All right. So put 9.34 times 10 to the negative 5th in standard notation. So the exponent is negative, so that means you're going to have a decimal as your answer. And you already have the decimal here, so you move it 1 spot, and there it's to the 5th right here. You see, to the 5th. So there's going to be 4 zeros out front. So 0.1234934 is in standard notation. All right. Now, put 0.037841 in scientific notation. You're starting with a decimal. So right away, you know that it's a decimal that's a less than 1. You know that it's going to be a negative exponent. So your coefficient is going to be moving this decimal 2 spots to between the 3 and the 7. So it's 3.7841 times 10 to the negative second. All right. And then this last one, 793.2034 put into scientific notation. It's greater than 1, so your exponent's going to be positive. You're moving to the left 2 spots. So it ends up being 7.932034 times 10 to the second power. So there you go. 4.629 times 10 to the 6th. You move it these 3 spots. You still got 3 more to go. You add the 3 zeros here. Okay, put into scientific notation. Your decimal's here. You got to move it 7 spots to between the 2 and the 7, and you get 10 to the 7th. Put 9.34 times 10 to the negative 5th in standard notation. Your exponent's negative, so it's going to be a decimal. Move it to 1 spot in front of the 9, and then you have 4 more to go. So it's 0.000093. And then 0.037841 put in scientific notation. It's going to be 2 spots, 3.7841 times 10 to the negative 2. And then finally, this last one, 793.2034. Move it 2 spots to the left, and it's going to be 7.932034 times 10 to the second. All right. So significant digits, not a big fan, going to be honest, but we're doing it anyway. One of the reasons why we do significant digits is we do it for accuracy and precision. The number of digits important to determine the accuracy and precision of a measurement is the most important thing that we can do because we want those numbers to be as accurate and as precise as possible. Okay. Number 2, they have rules. There's many rules when it comes to determining how many significant digits there are in each number. And you'll see why I struggle with the significant digit and understanding the logic behind it, because once we get into the rules, it's going to be very interesting. So number 3, measurement. In the end, it does make your measurements more accurate. and it also can make them more precise as well. Okay. And it's tricky. I'm not going to lie. There's so many rules that go with significant digits. So here are the rules. This is the last slide for today. The rules are all non-zero digits in a number are significant. So 652.1 has 4 significant digits, 82 has 2 significant digits, and 825.18 has 5 significant digits. So all non-zeros will always be significant. All zeros that are in between non-zero digits are also significant. 23.0041, they're all significant. 4,005, they're all significant. All 4. All zeros just before and just after a decimal point are not considered significant. So 0.007, and this is where my issue lies, 0.007 has 1 significant digit. So what you're telling me is those zeros don't matter. Well, if you take those zeros out of the number, it changes it completely because it's 7 1,000s. Now it turns into 7. And then the third one, the second one is 0.00000000000000000. 12 zeros in case you're counting at home. 789 only has 3 significant digits. All those zeros are what are considered placeholders. Fourth, zeros to the right of the decimal point are significant as long as there are no non-zero digits after them. So 25.00, all 4 are significant. 12.3900, all 6 are significant. Those zeros, the rule says those zeros have been put there for a reason, so they must be significant. Any measurement that you make, with or without a decimal point, all the digits are significant. 260 has 3 significant digits, okay? But any zero at the end of a number, except for a measurement, without a decimal, is not significant. So 10 has 1 significant digit. 100 has 1 significant digit. 100 point, all 3 become significant because there's a reason why that decimal has been put in. If it's not put in, then those zeros are not significant. If the decimal point is in, then those zeros become significant. Like I said, it's confusing, it's crazy, it's nutty, crazy stuff, but it is what it is. So that's scientific notation and significant digits. Tomorrow we'll do accuracy and precision. That's also another quick PowerPoint. It's like 7, I think, at most, not even. It's more like 4 slides. So that'll be quick. And then I'm thinking on Friday, you guys will have a Do Now quiz based on the 3rd and 4th lectures that you will be able to use your handwritten notes for, because I'll make sure that I close that Do Now quiz down for you. And then I think I'll probably do some sort of review over the weekend that I'll post for you guys on Monday. And I'm thinking Tuesday, we're going to have the Unit 1 test. So that's where we're at. If you have any questions, you know where I'm at. And I will talk to you later. Deuces.